Welcome back. Today we're doing something a little different. We're putting one of physics' most famous experiments on trial. Yeah, you heard that right. And we're going to crack this century-old case using one single incredibly powerful analogy.
So what if you had a master key, one that could unlock a mystery that has stumped physicists for over 100 years? Well, the source material we're looking at today says that key is actually a pretty simple idea. It's this. Think of every physical theory as a map. And you know how maps work, right? Each one is useful for something different, but every single one has some kind of distortion, and sometimes that distortion can be fatal.
All right, so to really dig into the Michelson-Morley experiment, we've got to get familiar with the three competing maps that physicists use to see the world.
And here they are. This is what's so cool about this whole approach. On the left, you've got different map projections, and on the right, the world views they line up with. You've got the classic Cartesian view, you've got special relativity, and then this third one, the source calls DE080. We'll get to that. It's going to be our judge. Now, the big takeaway here isn't about which map is right or wrong. It's about understanding what each map is good for and where its blind spots are.
Okay, let's set the stage. Time to meet the key players in our little courtroom drama. The prosecutor, the defense lawyer, and the judge. Each one represents one of those worldviews we just saw.
First up, representing the classical, old-school view, is the prosecutor. This guy sees the universe as this perfect, absolute grid, like a Mercator map. Everything is neat, the angles are precise, and all the action happens on a stage that never, ever moves.
But here's the problem, right? The source points out a huge, fatal flaw in this view. The prosecutor drew up his whole case assuming the courtroom was fixed in place. He totally forgot that the entire courthouse, I'm talking our whole solar system, is actually a spaceship blasting through the cosmos. All right, now for the defense lawyer. This is special relativity. And it's brilliant, but it's also totally self-centered. It's like one of those azimuthal maps where you are always, always at the center of your own universe. Think about a fighter pilot, right? For them, this is the only map that matters. The cockpit is stationary, and the whole world outside bends and twists and warps, all just to make sure the laws of physics stay consistent from their point of view.
And that's the key, Special relativity, in this analogy, isn't about objective reality. It's a survival map. It's the interface you need when you're in the pilot seat. It works, it's super useful, but it's not a picture of what's actually going on out there.
And that brings us to the judge. The judge represents this other perspective, the one the source calls DE080. And the idea here is, well, to get to the real truth, you have to get out of your own head. You have to step outside of any one perspective. The judge isn't looking at some flat, distorted map. Nope. The judge is like air traffic control, pulling in data from everyone, from all angles, to piece together the real 3D picture, the actual globe.
So for the judge, it's the system that's absolute, the whole electromagnetic field. And what you and I see, it's just an echo, a phantom made up of old light that's finally reaching our eyes. By the time we see something, reality has already happened and moved on. Kind of wild, right? Okay, let's see how this all plays out in the experiment.
All right, section 3. We're diving into the experiment itself. The whole case, the entire reason we're here, hinges on one single, very confusing piece of evidence: the results of the Michelson-Morley experiment. So here's the setup. Picture the Earth as this massive spaceship, hurtling along at 30 kilometers a second. Scientists built this gadget, an interferometer, to try and feel the wind, the ether wind, that our motion should be creating. The idea was simple: split a beam of light, send the two halves on different paths, and then bring them back together. They expected the wind to mess with the timing and create a specific pattern. But what did they find? Nothing. Nada. Zip. The result was null, and it basically broke physics for a while.
Okay, now it's time for the cross-examination. Let's see what the judge has to say about the arguments from our prosecutor and our defense lawyer. It's time to find the flaws in their maps. The prosecutor? His case gets tossed out of court almost immediately. Why? Because his whole map, his whole grid, was based on a stationary lab. He completely ignored the fact that the crime scene itself was moving. The mirrors were moving targets. Sorry, buddy. Case dismissed.
Now, the defense lawyer, with special relativity, that was a brilliant move. Totally saved the day, right? He argued that space itself squished and time stretched, all to make sure that from the scientist's perspective, the light beams came back together perfectly. And it works. But the source we're looking at says, hold on a second. That's a great explanation for what the pilot sees inside the cockpit. It doesn't actually explain where the light really went out there in objective 3D space. So if the classical map is wrong and the relativistic map is just a subjective view, then what in the world really happened? It's time for the judge to deliver the final verdict based on that 3D objective view of reality. And here it is, the big reveal. The whole thing wasn't some deep cosmic mystery. It was a simple aiming error. I mean, look, the light leaves the starting point, but while it's traveling, the whole machine, the mirrors, everything has moved forward. The light was aimed at where the mirror used to be, not where it was going to be. It's literally the first rule of shooting a moving target, right? You have to lead it, and they didn't. So here's the shocking truth from the judge's perspective. Those two beams of light were never, ever going to meet up again at the detector. It was impossible from the start. The very idea that you could get those interference fringes, well, that was based on a flawed assumption. A kind of geometric trick, thinking that light could go on these two completely different journeys through space and still, somehow, magically arrive at the same place at the same time. In the real moving world, no way. So that null result that baffled everyone? It wasn't some profound clue that space and time are bendy. It was just what you'd expect to see from a badly aimed experiment. According to this view, the scientists saw a blurry, messy image, and instead of thinking, maybe we missed, they decided the entire universe must have warped to explain it. They forgot the most basic rule of the hunt. You always, always have to lead a moving target.
Whew, okay, so what does all this mean? After this whole trial, what's the big takeaway from looking at these different maps of reality?
This really brings it all home. On one hand, you have special relativity, the fighter pilot's cockpit view. It's absolutely essential for survival, but it's your view, distorted to keep you safe. On the other hand, you have the judge's view, the Zainat-Chetpai perspective. That's like air traffic control. It's the objective, system-wide 3D view of where everything actually is. See the difference? Both are useful, for sure, but one is about your personal experience and the other is about objective reality. And that's the final idea I want to leave you with. Think about it. The light that's hitting your eyes right this second, allowing you to watch this, it's old news. It's from the past. Your brain is working like crazy all the time to build a useful map from all this delayed data. And it's a great map. It helps you navigate the world. But maybe, just maybe, we should never ever confuse the map inside our head with the real, vast, and constantly moving territory out there.